a planet so far away that light itself takes over 4 hours just to reach it. Winds up there blow 6 times stronger than the worst hurricane ever recorded on Earth, fast enough to break the sound barrier. A single season on this world lasts longer than most human lifetimes. And it is the only planet in our entire solar system that you could never see with your own eyes, no matter how clear the night, no matter how far you traveled, no matter how hard you looked. Not once in the entire history of human civilization has a single person ever spotted it just by looking up. This is Neptune. And for most of human history, it wasn't even a rumor. It didn't exist for us at all. Then, in 1989, a spacecraft humanity had launched 12 years earlier finally arrived, and for the first time gave us an actual photograph of this world. And now, decades later, the James Webb Space Telescope has turned its eye toward Neptune and captured something that left scientists genuinely stunned. If you want to see exactly what it found and understand just how strange this planet really is, stick with me. Because the final image in this story is one of the clearest looks at the edge of our solar system humanity has ever gotten. Welcome to the space frontier, where we bring you the real science behind the most extreme places in our universe. Let's start with the basic reality of where Neptune actually sits, because the numbers here are almost impossible to feel until you slow down and actually sit with them. Neptune sits roughly 4.5 billion kilometers from Earth. If you tried to drive there in a car at highway speed, never stopping for food, never stopping for sleep, never stopping at all, it would take you more than 5,000 years to arrive. You would have had to start that drive before the ancient Egyptians built the pyramids, and you still wouldn't be there yet. That's the kind of distance we're talking about. And that distance is exactly why humanity did not see this world's real face until 1989. Neptune is classified as an ice giant, and that name gives people the wrong idea immediately. It sounds like a frozen ball drifting silently through space, coated in something like the frost inside your freezer. The reality is stranger than that. The name actually refers to the planet's chemical makeup. Neptune is made largely of water, methane, and ammonia, but not in the solid, frozen form you're picturing. These materials exist in what scientists call a supercritical state, a bizarre condition where matter is neither fully liquid nor fully gas, but something blending both at once. Nothing like it naturally exists here on Earth. Only 2 planets in our solar system carry the ice giant title, Neptune and its neighbor Uranus, but Neptune stands apart in almost every way once you start looking closely. Just the scale of this planet is enough to humble anyone. Neptune's diameter is around 50,000 kilometers. Earth, the planet that feels enormous to every one of us living on its surface, measures about 12,700 kilometers across. That makes Neptune roughly 4 times wider than our entire planet. In terms of mass, the gap gets even more dramatic. Neptune weighs in at about 17 times the mass of Earth. Picture 17 Earths stacked on one side of a scale, barely balancing against a single Neptune on the other side. And here's a detail that surprises almost everyone the first time they hear it. Despite being so massive, Neptune actually spins faster than Earth does. One full day on Neptune, one complete rotation, takes only about 16 hours compared to our 24. But flip to the question of a year, and everything reverses. Because Neptune sits so far from the Sun, one full trip around its orbit takes about 165 Earth years. If you were born on Neptune and wanted to celebrate your very first birthday by the planet's own calendar, you would need to live to be 165 years old just to reach it. And the seasons stretch out just as absurdly. Neptune is tilted on its axis the same way Earth is, which creates seasons, but each individual season up there lasts more than 40 Earth years. Imagine a winter that started before your parents were even born, and it still hasn't ended by the time you're in your 40s. That's simply how time moves on this world, and scientists have actually been watching these long seasonal shifts play out in real cloud patterns and shifting brightness over the decades. They've had telescopes trained on it. The story of how we even found out Neptune existed at all is one of the most remarkable moments in the history of science, and it happened almost entirely on paper before anyone actually saw it. Galileo may have technically spotted Neptune all the way back in 1612, but he logged it simply as a background star, never realizing what he was actually looking at. For more than 2 centuries after that, Neptune stayed completely unconfirmed. What finally brought it into existence for us wasn't a telescope, it was mathematics. Astronomers studying the orbit of Uranus noticed something was tugging at it in a way the known planets couldn't explain. Multiple scientists ran the calculations independently and predicted that an unseen planet further out had to be responsible. In 1846, Neptune was confirmed, its existence essentially proven with pen and paper before anyone pointed a telescope at the exact right spot in the sky to actually find it. That is one of the greatest triumphs of scientific prediction in human history. And it's the reason Neptune carries the name of the Roman god of the sea. Because when astronomers finally did see that striking blue-green color through their telescopes, the name simply felt inevitable. That deep, unmistakable blue comes from methane sitting in Neptune's upper atmosphere. Sunlight hits the planet, and the methane absorbs the red end of that light, reflecting mostly blue back out toward our telescopes and cameras. Uranus has methane too, and shows a touch of that same blue, but Neptune's color runs far more vivid and intense, and scientists still aren't entirely sure why. Something else in Neptune's atmosphere appears to be deepening that blue even further, and that particular mystery is still being studied right now. But if you really want to understand what makes Neptune one of the most extreme places in the entire solar system, you need to talk about the wind. Neptune holds the record for the fastest winds ever measured on any planet we know of, reaching speeds of up to 2,100 kilometers an hour. The worst hurricane wind speed ever recorded here on Earth sits around 350 kilometers an hour, and that was enough to level entire towns. Neptune's winds run 6 times stronger than that, faster than the speed of sound. And here's what makes this genuinely puzzling to scientists. Neptune sits so far from the sun that it receives almost no solar energy, roughly 900 times less sunlight per square meter than Earth gets. Normally, the sun is the engine driving a planet's weather. Neptune barely gets any of that fuel at all, and yet it has the most violent atmosphere of any planet we've ever studied. The answer, scientists believe, is buried deep inside the planet itself. Neptune radiates far more energy outward than it ever receives from the sun, meaning it's carrying its own internal heat source, likely left over from the planet's formation billions of years ago, and that internal engine is what drives those record-breaking winds from the inside out. If you've made it this far and you're finding this as wild as I do, this is a great moment to hit subscribe, because we're just getting to the part where a spacecraft actually arrived at this planet and gave humanity its first real look, and what it found only made things stranger. Before 1989, everything we knew about Neptune came from mathematics, distant blurry telescope images, or pure theory. No human being had ever actually seen this world in any real detail. That changed with Voyager 2. Launched on August 20th, 1977, Voyager 2 was built to take advantage of a rare alignment of the outer planets, using each one's gravity to slingshot toward the next. It visited Jupiter, then Saturn, then Uranus, and finally arrived near Neptune in August of 1989, a full 12 years after leaving Earth. What it sent back remains, to this day, the only close-up visit any spacecraft has ever made to this planet. The images were extraordinary. People who had only ever known Neptune as a faint blue dot in a telescope suddenly saw a real, living world. Banded clouds moving at different speeds through the atmosphere, and a massive storm system in the southern hemisphere that scientists named the Great Dark Spot, an anticyclone roughly the size of Earth itself, with winds around its edges among the fastest ever measured. When the Hubble Space Telescope looked at Neptune again in the mid-90s, that storm had completely vanished, dissolved back into the atmosphere. More dark spots have appeared and disappeared since in different regions of the planet, which tells scientists these storms are dramatic but temporary. Nothing like Jupiter's Great Red Spot, which has held its shape for centuries. Voyager 2 also finally confirmed something scientists had suspected but couldn't prove from Earth, that Neptune has rings. But they're nothing like Saturn's. Saturn's rings are bright, dense, and made of countless ice and rock particles ranging from dust to house-sized chunks. Neptune's rings are far more subtle, thin bands of mostly microscopic dust, difficult to photograph even with strong equipment. And they're not even. Certain sections, called ring arcs, are noticeably denser and more concentrated than the rest, which explains why earlier Earth-based observations kept getting inconsistent results. Sometimes catching an arc, sometimes catching nothing at all. Scientists think small nearby moons use their gravity to hold those arcs together instead of letting the material spread out evenly, and exactly how that works is still being studied. Speaking of moons, before Voyager 2 arrived, we only knew of 2 moons orbiting Neptune. In a single flyby, it discovered 6 more, and the confirmed count has since grown to at least 14. The largest by far is Triton, and it might be the strangest single object in our entire solar system. Triton orbits Neptune backwards, moving opposite to the direction Neptune itself spins, something almost no other large moon in the solar system does. That backwards orbit is a massive clue. Scientists are confident Triton wasn't born alongside Neptune at all, but was a free-floating object from the distant Kuiper Belt, the same region where Pluto lives, captured by Neptune's gravity long ago. If that's true, the capture itself must have been violent, throwing any original moons Neptune had into chaos, sending them crashing into each other or flinging them out entirely. The smaller inner moons we see today may actually be leftover debris from that ancient collision event. Triton itself measures about 2,700 kilometers across, making it the 16th largest known object in the solar system. A little smaller than our own moon, but still a substantial world in its own right. When Voyager 2 photographed its surface, it found something nobody expected: active geysers. Not volcanic ones, nitrogen geysers, shooting columns of liquid nitrogen and dark dust miles up into Triton's thin atmosphere, where it drifts and falls back down, leaving dark streaks across the frozen ground that are clearly visible in the old Voyager images. Even the weak, distant sunlight reaching Triton is apparently enough to heat dark material beneath the surface ice and trigger these eruptions from below. And here's a genuinely strange fact to sit with. Because of that backwards orbit and the tidal forces slowly pulling Triton inward, scientists have calculated that in roughly 3.5 billion years. Neptune's gravity will tear this moon apart completely, and its remains will likely form a brand new ring system, possibly far more spectacular than the faint rings Neptune has now. It's already written into the math of their orbits. It's simply a matter of time. The most recently discovered moon, Hippocamp, was found in 2013 using Hubble Space Telescope images, and it's the smallest known moon in the entire Neptunian system, so small and dark that Voyager 2 completely missed it back in 1989. Then there's Naiad, discovered back in 1949, which holds one of the most eccentric, stretched-out orbits of any moon in the solar system, another likely scar from that same ancient chaos Triton's arrival caused. And there's Proteus, one of Voyager's discoveries, notable simply because of its shape. Most large moons are round because their own gravity pulls them into a sphere over time. Proteus never quite got there. It's lumpy, irregular, almost like a dark potato tumbling through space, and one of the darkest, least reflective objects we've ever found anywhere in the solar system. Before Voyager 2 flew past, humanity had no idea it even existed. Now let's actually talk about the temperatures on this planet, because they might be the most extreme contrast anywhere in our solar system. At the cloud tops, Neptune sits around negative 201 degrees Celsius, cold enough that the air itself would freeze solid around you in seconds if you were somehow standing there. But travel down through the layers toward the planet's core and everything flips. Temperatures near the core are believed to climb as high as 7,000 degrees Celsius, hotter than the surface of our own sun. That core itself is thought to be roughly Earth-sized, a dense rocky mixture of iron and nickel, buried beneath thousands of kilometers of superheated, super-pressurized fluid. That staggering gap between the frozen outer atmosphere and the blazing inner core is part of what fuels Neptune's entire internal heat engine. And it's exactly the energy source scientists believe is driving those record-breaking winds we talked about earlier. Voyager 2's flyby in 1989 wasn't the end of this story. It was really just the first real chapter. 1 year later, in 1990, the Hubble Space Telescope reached orbit, and while it could never match Voyager's up-close detail, it gave scientists something Voyager never could: the ability to watch Neptune continuously over years and decades instead of during one brief flyby. Through Hubble, astronomers tracked the great dark spot's disappearance, watched new dark spots form and vanish elsewhere on the planet, and followed the atmosphere's brightness shifting as Neptune moved slowly through its 40-year seasons. Hubble is also how Hippocamp, that tiny final moon, was finally spotted decades after Voyager had already passed by. And that finally brings us to, right now, to the discovery this entire video is actually about. The James Webb Space Telescope, launched in late 2021 and fully operational since 2022, turned its extraordinarily sensitive infrared vision toward Neptune, and what came back left the scientific community genuinely stunned. Webb captured Neptune's ring system with a level of clarity nobody had ever achieved before, not just the brighter main rings, but the faint, dusty bands that had always been maddeningly difficult to photograph from any previous instrument, Voyager included. In Webb's images, those rings appear sharp, clearly defined, and layered in a way that no photograph before it had ever managed to show. Webb also captured several of Neptune's moons sitting in the very same frame, giving scientists an entirely new perspective on the whole system at once: rings and moons together, something no single image had ever offered before. Looking at those pictures, after everything Voyager and Hubble had already shown us, genuinely felt like seeing this planet for the first time all over again. It's a reminder of something worth sitting with for a second. Every new tool humanity builds shows us something we simply couldn't see before. Neptune was invisible for the entire span of human history before 1846. Then it was a mathematical prediction. Then a blurry dot through a telescope. Then, for a few days in 1989, Voyager 2 gave us our first real close-up photographs of an actual world. And now, decades later, Webb has handed us the clearest picture of that world's rings and moons that has ever existed. There's one more thing about Neptune that deserves to be said, and it might be the most humbling detail in this entire story. Of every planet in our solar system, Neptune is the only one that has never once been visible to a person simply looking up at the night sky with nothing but their own eyes. Mercury, Venus, Mars, Jupiter, Saturn, even distant Uranus, every one of them can, under the right conditions, be spotted without a telescope. Neptune cannot. It's too far, too dim, too small in our sky. You need a telescope just to see it as the faintest bluish point of light. And yet this invisible, unreachable world has been quietly orbiting the very same star as us this entire time, tracing its slow 165-year path around the sun in the exact same solar system where our small blue planet spins and breathes and teems with life. Every other planet our ancient ancestors could watch move across the sky and build entire belief systems and calendars around. Neptune was simply never part of that story, not because it wasn't there, but because we had no way of knowing it existed at all. It took mathematics, telescopes, and eventually an actual spacecraft, flying 12 years through the dark to finally bring this world into view. So here's what I want to leave you with. Neptune looks calm in every photograph we've ever taken. That gorgeous, deep, tranquil blue immediately calling to mind our own oceans, exactly the way it struck the astronomers who named it after the Roman god of the sea. But underneath that serene surface sits one of the most violent, extreme environments anywhere in our solar system. Supersonic winds strong enough to flatten anything we've ever built. A core hotter than the sun itself, buried beneath an atmosphere cold enough to freeze the air around you. A giant moon slowly counting down toward its own eventual destruction. And rings we are only now, in the last few years, finally seeing clearly for the very first time. What Voyager 2 gave us in 1989 wasn't the end of Neptune's story. It was the opening page. What Webb has given us now is proof that story is still being written decades later, with better tools, revealing more of this planet's secrets every single time we look. If this gave you a genuinely new appreciation for just how strange the outer edge of our solar system really is, that's exactly what this channel is here for. Drop a comment telling me which fact from today actually surprised you the most. I read every single one. And if you want more deep dives like this one, go ahead and subscribe, because there's a lot more of the solar system left to explore. And some of what's coming next is even stranger than Neptune. Thanks for watching The Space Frontier, and I'll see you in the next one.